Now that we've talked about the structure and functionality of Java Phaser, let's go ahead and examine its key methods. As you can see from this diagram on the right, Phaser has a much more complex API than countdown latch or cyclic barrier. In particular, it has many methods that support a range of use cases. Fortunately, many of these methods are rarely used in practice, much like the upside-down airplane stamp that's rarely found in practice. There's a couple of constructors that create a new object that has an initial phase number of 0. Any thread that uses a phaser created with this constructor will need to register with it before using it. This constructor, in contrast, specifies a number of parties that are needed to advance to the next phase. This constructor is optional, however, since parties can always register with the phaser later, as we'll see in a minute. With phasers, the number of parties need not match the number of threads, which is more flexible than using a cyclic barrier in Java. Phaser also defines many methods that enable parties to register, synchronize, and terminate a phaser. Here are several methods that are used to register unarrived parties to a phaser. One of these methods, register, just goes ahead and registers one party, whereas bulk register will go ahead and register many parties. The number of registered parties dictates when a phaser can advance to the next phase. Going back to the analogy of the work crew, there might be a policy that says the work crew can only start to do the roofing when 7 roofers show up. Or perhaps you can only start to do plumbing when 5 plumbers show up. There's a number of methods that are used to arrive and/or await advancing to the next phase. As we'll see, having multiple methods provides flexibility with respect to arrival and waiting to advance. However, it also makes things more complicated to understand. This method, arrive, arrives at the phaser but does not block until other parties arrive. So it basically indicates it's there, but then it doesn't stick around. So it's a non-blocking method. This method returns the arrival phase number or a negative value if the phaser is already terminated. This method is rarely used in practice. There's another method called await advance, and this blocks until the phase of this phaser advances from the given phase value. As you can see, the phase value is the one that's passed there. This method will return immediately if the current phase doesn't equal the given phase. This method is also used rarely in practice. Finally, we run across the most common method, which is called arrive and await advance. This method arrives at the phaser and blocks until the other parties arrive. It's equivalent in effect to await advance, with the arrive method being used to pass in the arrival number. This method is in fact commonly used and is very similar to await on a Java cyclic barrier. This would be an example where a bunch of roofers would show up and they wouldn't start to do their work until all the roofers who were expected had showed up for the job site. There's also a method called arrive and deregister, and this arrives at the phaser and deregisters, decrements the number of parties that are waiting, without waiting for others to arrive. This reduces the number of parties required to advance in future phases. And this is often used by the party that controls the initialization of a phaser. This might be somewhat akin to having a foreman show up at the beginning of the day, check to make sure that people were there at the job site, make sure they were up and running, and then would go ahead and leave so that the future people who came to work wouldn't have to wait for that person to show up again. There's also an interesting hook method called onAdvance, and this performs an action upon a pending phase advance, trying to decide whether or not we should go to the next phase. This hook method is somewhat similar to the barrier action on a Java cyclic barrier, although as we'll see, it has more opportunities to control the way in which the phaser actually behaves. You can also use onAdvance to initiate termination by returning a true Boolean value from this method. By default, the implementation of onAdvance will terminate the phaser if no registered parties are there. This finishes our summary of the key methods in the Java phaser, and I think you'll agree that they're much more complicated and subtle than the equivalent API that you would find with countdown latch or cyclic barrier.